Right, greetings, I'm Professor Miller. Welcome to Math12, Mathematics of Lego. I'm going to just turn off my video and concentrate on the video being shown. I'm going to record today and then just post it amongst ourselves just for the fact that we have several people who are not able to make it today for various reasons. You can choose among COVID, international flights, national flights, and many, many other things. And so, not surprisingly, like everything in the past year or so, we need to be flexible and adjust things a little bit on the fly. And so I don't want to do too much today because we still have a couple of people who aren't able to join us. But at the same time, we really can't afford to wait too much longer if we're going to try to do some things in the confines of winter study. So what I was hoping to do today is talk about the mechanics of the SpeedBuild goal, talk a little bit about what we've done in the past, and get some feedback from those of you who are here today and those who are not here, feedback from them later as to what we think is feasible. So we're essentially going to lose most of the first week due to quarantine, flights, and issues with Lego's shipments. This is a good time to talk about general advice in life. You should always have a plan B. If you are doing something and you need a certain item to work, if at all possible, you should have a backup. You should have something else for it. And it is amazing how often in life that does not happen. So fortunately, we do have a plan B. I had bought the set earlier and done a trial run with my son to get a sense of what is it like, would this be a good set for a speed build? And so last night, he and I carefully disassembled the set and put it into, I believe, 32 different bags. So what I want to do is talk a little bit about the instructions. So hopefully everybody has taken a look at it by now. And so let me just go over here so I can, so there's a lot of history of the stuff in a variety of languages. And then they start getting into the different directions. Okay, so here we go. So the goal is a speed build, to be the fastest people in the world to build this from start to finish. Given that I don't think anybody has really tried to do this as a speed build, I think it's pretty safe to say that we will have the record. A couple of years ago, I did this with the 3,152-piece Superstar Destroyer. And the goal was to build it in 32 minutes, I'm sorry, in 10 minutes or less. And so the first year we just barely missed with on the order of 40 college students and a couple of elementary school kids. What happened was the very last thing that had to be attached, a very small thing, was built backwards. And so as we get deeper into the speed build, I'll talk about what we learned from those attempts in the past. The second year with about 60 people, we succeeded. And so we were able to build it in about 9 minutes with 60 people or so. This is a much easier set to do a speed build because it is very parallelizable. So winter study is supposed to be casual, it's supposed to be informal, it's a chance to explore, to have some fun, to do things you wouldn't normally do. This is not going to be a math intense class, but at the same time, I want to use this as a springboard to talk about some really good themes. And so parallelizable means it is a project that you can break up into different pieces that can be done independently and combined later. So does anybody know of a really good process in, say, science or math, a really good computation that's parallelizable? Anybody have any examples they want to share? So I'll give a couple. So one is, the search for large primes, because each computer can be independently checking a different set or checking different factors or whatnot, and then you could combine the stuff. There's the search for extraterrestrial intelligence, where they split up the work that needs to be done. There's the Human Genome Project, where they split up the work that needs to be done among several different computers, and then you combine the stuff later. So a lot of times you're very fortunate that you don't have to have A done before you do B, and you don't have to have B done before you do C. You can do A, B, and C simultaneously, and then combine them together. If you are doing various types of baking, there are a lot of things where you can make a bunch of things and then combine them later. And then they will reach the point where you just have to start now doing things sequentially. So, when you look at this, there are certain parts that should look obviously easy to split off. The green field, and we should probably decide, do we want to call this a soccer field or a football field? I'm open to either one, but the playing field, that's easily done as one thing. There's the 4 base plates on the gray areas that it's built on. That's another thing. And then there's the different stair areas. And so unlike some other sets here, it doesn't really give you a good picture of what you get when you're done with bag 1, but so here's bag 1, bag 2. Oh no, here it is. Here's the picture of the base plate that you get with bag 2. And then it's starting with bag 3 that we start to build the stairs and the seats. Did we go too far? Okay, so here's bag 3. And so bag 3 is building 2 of these stair areas. One of the great things in mathematics is the idea that you can often reduce a complicated problem to a lot of simpler problems. Is there anybody here who is good at tic-tac-toe? Okay, do you think you can beat me in tic-tac-toe?
Potentially.
You do? You think you could beat me in tic-tac-toe? Standard tic-tac-toe.
I think so.
All right, I'll play you. Do you want to go first or second?
First.
First. All right, I will go to a screen here. So now, so let's see. So hopefully now, I'm just trying, it's not letting me share my screen. This is interesting. Oh, here it is. Okay, here you go. Where would you like to go? I will even give you the first move.
I'd like the middle square.
Okay. How many choices did he have for the first move?
9.
9. How many choices do I have to respond?
8.
8. 9 times 8 is 72. How many choices does he have to respond to my response?
7.
7. So now we're at close to 500 games just for the first 3 moves. But what I claim is, actually, in some sense, I really don't have 8 responses. If I use the symmetry argument, how many responses do I have to his opening gambit? So if you look at this, how many responses? Hollow it out.
2.
2. I could either go in a corner, or I can go in the middle. So if I only have 2 responses if he goes in the center, how many responses do you think I have if he goes in one of the corners?
3.
3.
It's more than 3. What do you think the 3 are?
Middle corner side.
Okay, well, but see, not all the middles are the same. There's the middles that touch the X, and there's the middles that don't touch the X.
Yeah.
There's the corner that's along the same row or column, because we can flip, these are the same. So there's really 5 responses. And similarly, if he had gone in the middle initially, I would have 5 responses. There's really only 12 pairs of initial moves, not 72. That's a factor of 6 savings. Now, for modern day computer, a factor of 6 may not be noticeable because things are just so fast. I'm old enough that I remember, download speeds being measured in kilobytes and whatnot, and just how painful it was and how bad streaming video was. So any savings, any efficiencies you can do are wonderful. If we're going to try to do a speed build, if we're going to try to do this in under 10 minutes, any savings we can get is tremendous. So when I look at what's going on here, if he goes in the center, I only have two possible responses. So I only have to think about two possible gains. And so I am going to deliberately not do something that I should. I am not doing this move, but let's say I take one of the middles. And without loss of generality, I might as well take that middle. All I have to do is determine that this is a bad move, and I no longer have to analyze this. Where should he go next to put pressure on me?
The corner.
Which one?
The corner, the top left, or yeah, top left.
Okay, so if he goes top left, that's setting him up for 3 in a row. I can then respond over here, setting up 3 in a row. And then he can go here, blocking me and doing the best thing you can do in tic-tac-toe, setting himself up for 3 in a row 2 different ways. And so by doing that, I'm dead. Now, interestingly, if you had gone in this corner, is that the same?
No. Yeah.
Yeah, it's the same. Just, flip about the middle of the board. So we often talk about, axes of symmetry. So if I just flip about the middle, this is the same. One of the things we're going to talk about when we get to the math of Lego is how many ways are there to build objects by combining Lego. And a lot of times it comes down to, do you consider things that have mirror symmetry, that are reflections of each other, to be the same? Physically, they're not. You cannot, physically flip about the 4th dimension. Do I have any chemists here in the class? All right, doesn't sound like any chemists, but in chemistry, certain compounds can cure you while their mirror image can kill you. So we just saw that that corner is the same as the first corner. What if I go to this corner over here? Where would O have to go? Well, O has to go here to block. And now where can X go? And again, threaten 2 different ways to get 2 in a row.
Top left.
Yeah. And so when I said, after you said to go in the corner, when I said which corner, the correct answer is it doesn't matter. Any corner is enough to kill me. So I don't really have to analyze this. Once I found that there was one winning path for, I believe it was Matt, I know I don't want to go in the middle. And this is where I get to use my do-over. As the professor said, well, I deliberately said I'm not going to do that. So I now know I have to go here. How many choices does Matt have to respond to me?
Four.
And so, again, the whole point is to try to keep this to a manageable task. The larger the task is, the harder it's going to be for me to fully analyze this. So since you said you think you can beat me, where would you like to move now? And you are welcome to use a lifeline and ask the class. Where is the worst possible move for Matt? Let's start off with what's a really bad place.
Yeah, I'll phone a friend here. Someone hop in.
Top left, bad.
Yeah, again, you would have to go through the analysis, but it seems like the top left is probably the worst possible thing you can do, because it doesn't continue the attack and it gives me a chance to now start my own attack. This is not helping you get 3 in a row. So almost surely that's the worst thing that could be done. So any thoughts as to where Matt should go?
Bottom left.
Bottom left. Bottom left corner?
Yes. Yeah.
Yes. Now, what's nice here is really, I don't have to think. Right? My goal is not to win. My goal is to prevent Matt from winning. Matt has 2 in a row. My move is forced. I have to go here. But I'm fortunate now. By going there, what does that do to Matt?
Now I have to defend.
Now Matt has to defend. And now my move is forced. And at this point now, what is the only way Matt can get 3 in a row?
Vertical.
The only way is the vertical. There's 2 openings in the vertical. So Matt takes 1, and then on my next turn, I go and I stop. So this is enough to prove that that doesn't work. If instead of going there, if Matt went here, when I go to block, that's a little bit better for Matt in the sense that his move is not forced to stop me from getting 3 in a row, but he doesn't have the same flexibility in terms of trying to get 3 in a row himself. And so you can just go through all the analysis, and you can show very quickly that if you play tic-tac-toe well, that there is no way you're going to lose. It's going to be a draw. If people are interested, email me and I'm happy to share. There are variants of tic-tac-toe that are interesting, that have some really great mathematics. There's bidding tic-tac-toe. And what you can do is you can actually put some stuff in this to take into account that you might be playing with somebody who has more expertise. And you can actually handicap like you might do in a golf game. So why am I talking about this in a Lego class? This is a great example of symmetry. And by using this notion of symmetry, I took a very complicated problem and I reduced it and I tried to make it an easier one. When we were looking at what's going on, someone in the class already emailed me about what bags they wanted to do. And they noticed that a lot of the stuff is very similar. Because we're doing things 4 times, as we go around the stadium in fourths, if you're building bag 3, you might also want to build, maybe it was, I think, bag 9, in terms of just what you're trying to do. And so a lot of this is going to depend on how many of your friends you can convince to do this with us. The more people we have, the better chance we have of getting a really good time. We are fortunate to have 2 students joining us from Oxford, but unfortunately, I think they're only here till around the 17th. So in terms of manpower, we have 2 more people, but we only have them for a certain amount of time. So the question is, do we think we can get ready for the speed build by the 17th? I'm quite happy to really, push forward along these lines. What I would love for you to do is to record every time you're doing things, how long it takes you, and just get some data for what happens to your time as you practice more and more. Can anybody give me any thoughts as to what should happen if you spend, say, 5 hours a day for 10 days working just on bag 3? What should happen?
Should get very fast at it.
It should get very fast. Okay, but this is a math class, so you got to quantify it a little bit. Do you think you're going to have a uniform? So let's say we do a plot. So what we're going to do is, number of days, and we're going to do time for the bag. And let's say we initially start off with, this is how long it takes us in the very first build that we do. What do you think should happen as we do more and more practices?
I think your time will get increased significantly on the second one, and then, or get better more significantly on the second one, and then less so as you keep going.
Okay, so maybe we have some really rapid drop off, and then it's basically flattening out. And you might reach the point where at some point you're going to get into your physical limitations and you just can't do any better. Or what might happen is you might have something like this, which is really interesting. What do you think that might represent?
Maybe you finally
new-
stop looking at the instructions or something like that. So, there's a
So
big
one thing
chunk of
is
time.
you might reach the point where you're no longer looking at the instruction. There's some major shift in how you're doing things. You might find a new way of building that, wait a minute, if I build it in a different way, I might be able to do it much better. And in fact, rather than something like that, it might actually look more like this. Oh, yeah. Let me just blow it up a little bit. So you might initially have a increase in how long it takes you to do something as you find a new, wait a minute, this might be better. And then it takes you a while to become comfortable with that new way. And so again, a lot of this is about trying to find the most efficient way to do things. A lot of this is going to depend on how many people we have. So one of the things I really want you to think about for the rest of your life is, what do you keep doing again and again and again, and how can you do it more efficiently? Saving hours, saving minutes of the day is one of the best things you can do in your life. It's going to pay you dividends forever and ever and ever. And there are numerous applications. So let me give you an example of one of my favorite things. So let's say I give you a polynomial, 3x to the fourth plus 5x cubed minus 2x squared plus 8x plus 3. Okay, and we want to figure out, how long does it take to evaluate this polynomial if x is a huge number, like 10 to the 200? And numbers like that arise in modern cryptography. They arise when you're sending information in a secure way. So we really need to be able to look at polynomials with very large arguments. Now, because I'm writing this, I'm having my highest exponent be 4, but in practice, the exponent would be of size 10 to the 200 as well. And we can only do this for special polynomials. Does anybody want to guess as to how many multiplications does it take to calculate 3x to the 4th? How many multiplications do you have to do to get 3x to the 4th?
5.
5. X times x is 1, times x is 2, times x is 3. Oh, wait, 5? I think it might be 4. And then times 3, I think it's just 4. It's 3 times x times x times x times x. So I think it's only 4 multiplications. So this would be 4 multiplications. How many multiplications would that be?
3.
3.
And the next? 2, 1, and 0. And now we need to add all of these. And so if you add them all up, you should get 10. More generally, if I give you a polynomial a dx to the d plus all the way down to a0, the number of multiplications is going to be d plus 1 over 2. And I'll prove that in a second. Now, you might say that when I'm looking at evaluating this polynomial, I'm ignoring something. What am I ignoring?
Addition and subtraction.
Yeah, I'm ignoring the addition and subtraction. And the reason is, if you think about a 10 to the 200 digit number, that's 200 digits. If I want to add 2 huge numbers like that, well, I add digit by digit, that's going to be on the order of 200 additions. If this carries, fine, it's on the order of 400 additions. It's not a big deal. But if you multiply a 200 digit number with a 200 digit number, that's on the order of 200 squared, right? So the multiplication is far more expensive than addition. And so for something like this, we really want to focus on what matters. The multiplication is so expensive compared to the addition that the addition is just noise. You can think about this for almost everything in life. You can consider COVID policy and choices. What do you want to focus your resources on? Where are you going to make the most difference? Where are you going to have the biggest impact? So when we look at this, I claim if you have a polynomial of degree d, the number of multiplications is d plus 1 over 2. And there's lots of proofs. One of the most famous, can I start adding at 0 without making a difference? It's not going to change anything. So if I call that my sum, what I could do is I can write the sum backwards. I could start off with d. And now if I add them, I just get twice my sum. But what's 0 plus d? 0 plus d is just
D.
D,
d. And 1 plus d minus 1 is just
D.
d. So every sum is just d. How many sums do I have?
D plus 1.
D plus 1. So d times d plus 1 equals 2 times my sum. So my sum is just 1/2 d plus 1, which is approximately d squared. I don't really care about the factor of 1/2. I don't care about the plus 1. This tells me it's growing quadratically with d. Okay, why am I talking about this? There are very, very minimal math prerequisites for this class. This is listed as a math class, but calculus is not required, but basic algebra is. So I am assuming everybody has evaluated a polynomial at some time in their life that you've all suffered through an Algebra 1, Algebra 2 class. If you haven't, please let me know. But this is hopefully something you've all seen before, and you've done time and time again. What I want to do is I want to show you a better way of doing this. And this is going to be what I want you to be keeping in mind, not just for the speed build and the class, but for the rest of your life. That just because you've done something the same way day after day after day, doesn't mean that that's the best way to do things. Okay? And I will explain why shortly. So this is called Horner's algorithm. So imagine the polynomial was 3x to the 4th. I don't remember exactly what it was. I don't really care. So I'm going to just write a new one. 7x squared plus 5x minus 2. 3x plus 8 times x plus, I'm sorry, not plus, minus 7 times x plus 5 times x and then minus 2. So if you look at this, if you expand everything out, I have 3x, and then that hits the red x, that gives me 3x squared. It then hits the green x, that gives me 3x cubed, and then hits the yellow x, or the gold x, and gives me 3x to the 4th. The 8 hits the red x and gives me 8x, then hits the green x, gives me 8x squared, then hits the gold x and gives me 8x cubed. So this is the same polynomial. But now when you count multiplications, how many multiplications do I have? This is my first, 3 times x. When I multiply by x, that's my second. When I multiply by x, that's my third. When I multiply by x, that's my 4th. I've reduced it to 4 multiplications. And so in general, if I have a polynomial degree d, rather than taking on the order of d squared multiplications, it only takes on the order of d multiplications. There's a much better way of doing this. And this is what you need to think about when you're looking at the instructions. You can do even better, but only if you work with specific polynomials. So for general polynomials, this is the best we can do. Why am I telling you this? How do you think these instructions were made? What were they made for?
one person.
One person. They're made for probably one person, or maybe a parent with their kids, or maybe a couple of friends getting together and you're doing it. And so the way they're making these instructions may not be the best way to assemble it, especially if you have a large number of people. The more people we have, the more freedom we have to explore and find better ways to do things. What you might be doing is having one person making a bunch of the bottoms, someone else making a bunch of tops and putting it together. Until we know how many of your friends and colleagues we can rope in, we really don't know what's the best we're going to be able to do. I am still investigating to see if we can get the elementary school kids to join us. We have some 5th graders, and I know there's other kids who would be interested in joining us. They're really good because they're old enough that they are useful. Their hands are small, they can get in. They are, I think, a real asset if we can get them in. But I don't know if we will be able to have them come to campus. So when you look at this, there's a lot of symmetry in what's going on. And you're given that you're building two things, rather than building one all the way from the beginning, it might be easier to just build a bunch of things and then assemble them later. When we did the Superstar Destroyer, there was one person whose job was to find a certain piece because we needed that piece very early in one of the builds. And until we found it, it would hold things up. And so someone's job was when the bag opens up and is ripped, they just keep looking until they can find that piece. So again, the more people we have, the more freedom we have in terms of what inefficiencies are we able to accept. So right now we have, I think, on the order of 16 people with 32 bags. So that means roughly 2 bags per person. So if we're not able to find a lot of friends, the question becomes, how quickly are you able to build this? So what's nice is there's going to be, as I said, a lot of symmetry. So there should be 4 bags that are very, very similar. The bags are numbered, so it won't be that bad to, split them up. But it will take some time in the beginning of just distributing things. One of the big challenges is putting the stickers on later. And we might decide we want to do the speed build without stickers. I don't know. We'll think about that as we go. But I'm really interested in everybody having a personal log and just seeing how quickly you can build things and how long it takes before you reach the point where you no longer need to look at the directions. One of the most important lessons from the first time I did this was the need to practice failure. And there's lots of different ways things can go wrong. In the second build, the first year, some of the early bags were just taking a long time, but building the giant wings going along the 2 sides of the Superstar Destroyer, they were being done in about 3 to 4 minutes. So we took the people who could do those wings and we moved them to other bags to help out. And then they would help out for about 3 minutes, and then they would move to their bag because we didn't need their wings done until everything else was ready. And unfortunately, the second time we were building, one of the teams was nervous and they dropped their bag, and what they had built, which was already a good chunk of it, broke into pieces. And they hadn't practiced failure. And so the question is, what should you do in a situation like that? They chose to try to fix it on the spot. And they were unfortunately off by 1 row when they did this. And so it didn't align, and they spent a large amount of time trying to fix it. In the end, paradoxically, they had enough time that they should have just destroyed everything and go back to completely unassembled wing because they know how to do that. When we did this the first year, we did this in Pereski. The second year, we did this at the 62 Center. I'm not sure we were going to be able to do it this year. What I found was people who are used to performing in public were very energized by the crowd. Other people were quite nervous to have people looking at them. I was an extreme introvert until graduate school, when one of my friends told me I should run for social chair, which I thought was an interesting idea since I didn't really like being with people. It was one of the best things that I ever did in graduate school. It got me very comfortable talking to people and performing in public. And so it's much easier to do a lot of things when people aren't watching you, when they're not looking at you. I don't know what the build is going to be like this year, but I do know you want to get comfortable doing things in public. This is a really good skill to have. This is one of the benefits you get from doing various types of sports and extracurricular activities. So anyways, when you start choosing your bag and hopefully your team, what you want to do is you want to really look at the directions and see at some point, is this the way you want to build it? For the speed builds, we never really had anybody looking at the directions. Everybody had this stuff completely mastered. And then, as I said, we want to practice dealing with mistakes. What happens if something isn't working? Let's try to think about all the ways that things could go wrong and plan accordingly. All right, so I've been talking for a little bit. Any questions up till now? Okay. So, again, if you start looking at the instructions you can see this is what bag 3 is. Let me just, and you can start to see the details and whatnot. Okay, there seems to be a little bit of a delay. Okay, and now here is the next step, or the end of the step, is attaching this to the plate. When do you think we're going to want to attach it to the plate?
After the play is finished.
After the plate is finished, right? We can't attach it before the plate is finished.
Mhm.
And so, normally, if you have just one or a small number of people building things, you'll of course completely build the whole plate before this is done. The plate, I think, is going to be able to be built pretty quickly. And then, if you notice the plate, it should be screaming at you that it's very natural to attach one thing to it, but do you think you can attach anything else directly to the plate?
Just the
What do you
grass,
mean?
probably.
I'm sorry? Yeah, the
The gr-
grass, you can see two rods sticking out. And so those two rods sticking out can almost surely be attached into the green. And so those rods would be right over here. You can attach another plate over here, and it may be hard to see. Yeah, can't really see, but there'll be two other rods sticking out over here so that you can attach it. Do you think we can attach any more stands to this? To the plate directly?
No.
No. So how do you think we're going to attach the next stand?
To the other stand,
Yeah, where do you see that happening?
the red and the blue diagonal pieces, maybe.
Okay, so one possibility is you might have things snapping in here.
Wait, I
There's
think
another
it's the gray one. I think it's
Yeah,
the gray
if you-
one.
If you look
Yeah.
over here, you have two gray handshakes coming out.
Yeah.
And so when you look at the bags, which do you think is the most important to be fastest on? Bag 3, 4, 5, 6, 7, or 8?
Back 3.
Yeah, bag 3. So when you're trying to decide, which one to do, 3 is the one that's going to have to be done first, because we can't attach, bag 4, or could we? Could we attach a bunch of the others if we don't have bag 3 done, and just attach them to each other and then attach that to bag 3 later? So, these are things that you need to think about as to, in an ideal world, bag 3 would be done, then bag 4, then bag 5, and you would attach them linearly. But maybe as we're trying to save time, you maybe attach, 3, 4, 5, and maybe you attach, 6, 7, 8, and then you attach them together. It looks like it's going to be very easy for things to snap off. So these are things we're going to have to check many times. What's nice is it's going to be pretty easy to do lots of practice builds of these, because unlike the Superstar, it really can be segregated into different sections without too much trouble. And this is why, after a lot of research, my kids and I decided that this would be a really good set to try to do a speed build on, because it's so parallelizable. And again, this is just a really great concept to be aware of. And so now, whoops. So now this is looking at the next, I'm sorry. So this was the end of bag 1, so bag 3. So this is bag 4, I believe. Well, maybe this is the second part of bag 3. Maybe this is the next part of bag 3, because I think there's 2 for each one. Right, and then, right, so this is the second part of bag 3, and then we snap them together. And now we do bag 4, and if you look, you can see for bag 4, it's going to give us 2 more sections. And so my son noted last night that every one of these bags is going to be 2 sections. And so we would then build 2 more, and you can notice that it's going to be coming in at a bit of a curve. So it's really cool how they make the curving happen. Let's see. So right, so over here, this is something we're going to need to think about as to how are we going to be doing the stickers. You know, do we have somebody whose job it is to put the stickers on and they just go from bag to bag because the stickers are only in certain areas? Again, there's lots of things to think about. And then once we build some of these, we move on. And again, the more people we have, the more you can break things up and have people building subparts and then having other people combine them. All right, so I'll just finish this bag over here. And then you have the next set of steps, and then you would combine that one, and then you would do a similar one to get the fourth one, and so on and so on and so on. So the big homework I want you all to do for today is to think about, who among your friends and colleagues do you have who would be interested in helping in a project like this? Because it makes a tremendous difference if we have on the order of 20 people or if we have on the order of 60 people. The next question is, what do you think is a reasonable time goal to have? And it's hard to do that until you do any builds. So before we did the build the first year, I did some quick calculations based on the size of the class of around 40 people. How many bricks per second do I think people could do? And I thought 10 minutes would be a reasonable goal. And at first it seemed completely unreasonable that we just couldn't get it below 30 minutes. And then we started chipping it down, chipping it down, chipping it down. But we were stuck a little bit above 10 until we made some fundamental shifts. And again, the purpose of this class is to just give you a sense of what's out there in mathematics. Part of this was almost dynamic programming theory, is that you allocate your resources as needed. And this is what I was telling you, is we pulled people from some bags and said, well, look, we don't need this stuff done until the end. So let's have them work on earlier bags in the beginning. We had a couple of elementary school kids building the center compartment where Darth Vader commanded, and they were taking about 8 minutes to do, but we didn't really need it earlier than 8.5, 9 minutes. So it wasn't a problem that it was taking them 8 minutes to do. So we need to really be aware of what the different skills are, how many people we have to make good, efficient decisions. Okay, so again, the homework for today is to really talk to your friends and see how many people you can get to help us with this. And again, if you look at these instructions, they're not that hard builds. There's not that many steps to learn. So I really think that there is a possibility of doing this in 10 minutes. The question was, with enough people, can we get it down to 5 minutes? At some point, you run into issues of just physically snapping the pieces together and not getting in each other's way. That there is some fundamental level that you can't go below. So I love doing Rubik's Cubes. If anybody's interested, I'm happy to do some sessions about teaching how to do Rubik's Cubes. But at some point, if you plot the time it takes the world champions to solve a Rubik's Cube, it's going to be similar to how long it takes you to do this. You're going to see remarkable improvement in the beginning, and then it reaches the point where it's essentially stabilizing, and there's very little gain as time is passing now. All right, so any questions about the speed build?
I have a question.
Yes.
So are we supposed to disassemble all the parts after we speed build?
Yes.
Every time after the practice, do we need to
every time after the practice? Well, yes.
Oh, okay.
And then I basically rated the house for as many bags as I could find yesterday. Some of the bags are not the greatest, but I got 32 bags. So everything is in a bag. Most of the bags are resealable. And so it's very segmentable. So you will have your bag that you're responsible for. Do not lose the pieces.
Okay,
and then
thank you.
Yep. And then just build it, time how long it takes, and just record that. It would be interesting, you can decide how much information you want to include when you're recording. Maybe we could set up a Google Sheet. What information do you think might matter in terms of trying to decide how well you build? What could impact that? So what could influence how well you build? All right, so I'm going to call somebody up randomly at 2 a.m. tomorrow. The bag will be outside your door. Do you think this is going to be the best indicator of how well you build?
No.
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 So time of day could greatly impact. What else could impact how well you build?
Like
If you've
your
eaten.
nutrition.
Your nutrition. Are you hungry? Do you think you build better right after eating? Do you think you build better maybe an hour or two before, hour or two after? Are there certain times when you are better? What also could impact it is how many builds have you just done? If you've just done 10 builds, are you getting to the point where you're just tired and you want to stop building? Or are you at the point where you're in a groove? You're different people, I could see having very different results. Whenever you are doing an experiment, you want to collect as much data as you can, because it's often cheap to collect the data at the time, but expensive to go back and do it later. So when you're recording your builds, what you might want to do is you might want to record not just how long the build was, but the date and the time. And if you record the date and the time, that should give us almost all the information. We can then just look and see, oh, okay, this is your fourth build in a row. So you might be somebody who gets into a groove, or you might be somebody who, if you do it too many times, you start getting bored and careless. We can see, time of day to see, maybe you're groggy in the morning. And so if you record, if you just think a little bit and record all that stuff in the beginning, we will have that, and it'll be, I think, a more interesting, accurate data set.
Professor, I have another question.
Yes.
So are we gonna sort the breaks according to their color or size before our speed build?
No.
Oh,
no, because
okay.
the speed build is going to be from an unopened box.
Oh, okay, I see.
So the goal is we're going to open the box, and then one of the problems is going to be we have to distribute the pieces, the bags, to everybody. Which means we also have to think about how are we going to open the bags. We have to think about the physical layout of where are we going to do this. And so you could decide that it is beneficial to sort the pieces first and then build, or maybe to do a partial sort. My feeling is it's probably not a good idea to spend too much time sorting, because the clock is ticking. Also, the more you build, the easier it becomes to find future pieces. But what you want to do is you want to try to simulate. So when you're done building, you will disassemble it and just put all the pieces together. Now, one of the things which I can't remember, and we won't be able to tell until we get to the box, is sometimes what Lego does is they might have bag 3, but bag 3 might actually be 2 bag 3s. You might have 2 big bags. You might have a big bag and a small bag. And so there will be some time that will be lost. Do you think it would be advantageous if there was a bag of big pieces and a bag of small pieces?
Yeah, that might improve the efficiency.
Right, because then when you
easier
open them,
to-
you might say, okay, I'm going to put the small pieces here, the big pieces here.
Yeah.
And so, one of the nice things about being the professor is you get to choose, what the rules are. You guys have, of course, tremendous input in what they're going to be. I don't consider it cheating to open up the, one of the boxes and just see what the different bags look like and record that, and then just seal the box again, and we just have to reopen it, and just put tape back on it. To me, that's not cheating, because we could just open another box and record that information. So it will become valuable once Lego finally ships the stuff, to actually see how are the pieces divided. Okay, any other questions? So we are not going to be in Ripley's Believe It or Not. The last time I talked to them about this, they were willing to come and record the speed build of the Superstar Destroyer, but they wanted $7,000. And while Williams does have a lot of money, to me, it's just not quite worth spending $7,000, to be officially in this. But what I do want to do is have, some really good camera crews, filming this and doing a, really good, video montage of having it assembled. We had an okay one the first year when we did it, but it was essentially only focused on the main table. It didn't really see what was going on the other tables, which is, of course, a challenge when you have 32 bags and so many things going on. If we have on the order of 16 people, that means you might be responsible for building on the order of 4 things. And so I do think 10 minutes with a reasonable number of friends is doable. With an unlimited number of people, I think it's possible to get down to 5 minutes. Less than 5, I'm starting to think it's going to be too hard. It's the old phrase, too many chefs in the kitchen. At some point, you're going to get in each other's way. How many of you have heard of the museum security guard problem? Why do museums hire security guards?
To protect what's in the museums?
Protect what's in the museums. So imagine a security guard makes, let's say, $50,000. And if you have no security guards, that's probably going to be disastrous for the museum, right? But after a while, once you have one security guard, for instance, in each room, how much value are you getting by adding that additional security guard?
Yeah, it just decreases.
Well, hopefully the value will never be negative. Hopefully the worst that will happen is that it's no longer protecting any thefts. Or maybe the amount of thefts it's protecting is so small, it's just not worth the cost of the security guard. Has anybody ever lost a credit card or had a credit card stolen? I won't ask if anybody's ever stolen a credit card. Just, have you ever lost a credit card or had a credit card stolen? All right, so James, when you lost your credit card or had it stolen, what did you do?
Called to get it canceled.
Called and get it canceled. And how much were you liable for?
I'm not sure, honestly. I think, well, it depends on like how much they spent, right? Like once it was stolen.
Usually you're not liable for anything. And so I do a lot of research on something called Benford's law of digit bias. So for a lot of data sets, you're more likely to start with a 1 than with a 9. And there was this big bank, and they were doing an internal audit, and they noticed that a lot of internal numbers were starting with 4, a lot more than there should have been. They investigated further, and they saw that there were a lot of 4 8s and 4 9s for the first 2 digits. They investigated further, and they saw a lot of these were around $4,800, $4,900. And the reason was the bank had a policy. If your credit card is stolen or lost and you call and report it, the bank says, we're going to cancel the card. You're not responsible for the charges. Anything below $5,000, it wasn't worth the bank's time to investigate and try to find. If they hire an investigator who costs $1,000 and they find out that somebody stole your card and before it was canceled, they filled up their car with gas, although I guess that's a little bit expensive nowadays, and got a few candy bars from the convenience store. Let's say they spent $60. It's not worth spending $1,000 to get back $60. Unless that becomes such a huge deterrent, it prevents other people in the future. You're not going to spend $1,000 to get back 60. So the bank's policy was they just wrote off anything. They just said, all right, we're going to just eat the loss. And if it was above $5,000, then that was real money and they investigated. So somebody working at the bank was having their friends sign up for credit cards and run up debts just below $5,000. And they would call, and they would just keep calling until it was their friend who picked up the phone. Oh, your credit card's been stolen. Oh, that's awful. We're going to cancel your credit card right now. Don't worry, you're not liable for anything. And so they did this a large number of times before they were caught and had, built the bank out of a lot of money. But the way they were able to do this is they were trying to stay below the radar. They were trying to do something that would not, flag. And so there's, tremendous amounts of, really interesting, applications of mathematics, in the world around us when we're, trying to look at what's going on. Right. Anything else? All right, so again, for tomorrow, I want everybody to think about what bags you want to do. I've added something on the Google Sheet to give you a place where you can sign up and say what you want to build. So let me see if I can switch to that. Okay, yes. So good. So we've already got some people. You don't have to put names. You can just put right now the number of friends that you want to help. And then, you can put down, what bag you want to do. And if, you can put down several bags here. So for instance, if you want to do bag either 2, 5, or 7, you could put something like that. Again, there's some symmetries. I think bag 3 is the same as bag 9. So those would be, probably 2 good ones to do. And then let's try to get a sense of what resources we have, and then let's meet tomorrow. So does 1 o'clock work for everybody tomorrow?
Yes.
Okay. And then for those who wanted to go to the elementary school, hopefully you'll be able to join me next week, and hopefully we'll be able to get the elementary school kids to go. So I will say goodbye to everyone. I'm going to stop recording now.